Hello and welcome to part 4 of this tutorial series. Last time what we did was we created this Cellular Automata script, which you see here on the screen, and let me just enable the preview. So we did this kind of automated game of life generation. So if you haven't done this, you should definitely check that out, because we'll be working with 3D models that we get from it by meshing this point cloud here. Right. So in this tutorial, what we're going to learn is going to learn how to set up your 3D models so that they are so that you're able to 3D print them. We'll be using software called Cura to slice them up, and I'll show 3 different ways you can slice it for 3 different machines. Those machines are the ones that we have in LTH in Lund University, but basically the settings of them are pretty simple and pretty similar to machines in any other university out there. So that should the knowledge base should transfer quite well. So to start things off, basically we have like these 3 variants of the bounding box for our 3D prints. The first one is if we want to have something that's cube shaped, we'll probably end up using something like 10 by 10 by 10 centimeters. For a slab or wall type bounding box, we'll be using like 15 in X, 15 in Y, and 5 in Z. And for column type, we'll be using 7 by 7 by 19 centimeters. We cannot exceed 19 centimeters because only one of our machines can print higher than a 20 centimeter shape. So we're sticking to the 19 centimeter cap in height. So to start things off, how do we change? How do we generate a cellular automata that has the correct size? Let's start with a cube with of 10 by 10 by 10 centimeters. If I go back here, I can see that my starting grid is the step size, the grid spacing is 10 units, and my XY amount is 10, right? So that means that here, if I zoom in here, I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9. In total, I have 9 cells, which result in me having like a 9 centimeter print, because 10 units, and our units are millimeters, 10 units correspond to 1 centimeter, right? So even though here it says 10, actually what we're gonna end up with is a 9 centimeter print in X and Y. So I can basically increase this to 11. So now it's 10 by 10 centimeters and 11 by 11 cells, or divisions. And here, if now I rerun the loop, actually let me show you the point cloud as well. If I rerun the loop, it's going to calculate it in a 10 by 10 centimeter grid, right? So now the question is, how high can we go? And since we're working with a cube, we should have repetition set to 10, right? So basically what we want is we want 10 generations of this. I'll change up a pattern a little bit. Maybe add, let me just copy this somewhere here, maybe here. Let me reset here. So I've changed the pattern a little bit, and let's just see how it meshes out. So I'll disable the point cloud display. I'll run it through the data dam and check it meshed out, right? So we end up with something like this, and at this point I'm not looking for a pattern or anything, but you should definitely try to search for some sort of a pattern. But basically what we get here, if I were to bake this out, this would be a 10 by 10 by 10 centimeter shape, right? So that's for a cube bounding box. For a slab or wall type bounding box, we have 15 by 15 by 5, right? So let's see it. Let's use, so if it's 15, here we need to use 16 for X and Y, and 5 here. Let me run the simulation again. Reset, reset, and let's just check it out as a mesh, right? So it's nothing really fancy. Here you need so much more, many more initial segments, initial cells for this to work. So I'll just add a few, right? So let's say we have something like this going on and something like that. Right now I'm just doing it randomly, just to fill up the space. That. Perhaps something like this. Let me just copy it a few places. Like that. And like that. Yeah, that's good enough. So let me reset the layers. And let me run it again. Okay. We end up with something like this, right? So this is with the ISO value of 0.3, which makes it look quite blobby. If you want it to be more sharp or more crisp, you need to increase the ISO value. So in my case, I tend to use 0.7. That for me gives the most aesthetically pleasing results, which are still 3D printable. And I'll bake this out to my default layer. Okay, so that's my slab right here. And keep in mind that this one, let me change this to Arctic view. This one was done with 0.3 ISO value, while this one was done with 0.7. So you can see how much thinner and sharper this structure is compared to this one. You could achieve the same kind of aesthetic logic of the structure in here as well, if you were just to change the ISO value. Let me go back to shaded view. So now for a tower or a column type, we have 7 by 7 by 19, right? So I'm going to change this one, XY amount, to 8, so that we have so that we have 7 by 7 centimeters. Let me delete these ones because we don't need them anymore. Hard to see. Let me hide the mesh. There we go. Like this. So that's my starting position. Maybe I'll even change this up a little bit, and I'll just use something like, let's try out this. Yes, something like that. And perhaps something like this. Let's try this one out. Run it. Check out the point cloud. All right, and we need higher repetition amount, right, to have more steps in Z. So since it's 19 centimeters, we just use 19 repetition steps, and we let it grow like that. Hide the preview of the points. run the info through the data dam, hit the preview, and we just check it out. This one seems to be quite nice. I'll just bake it out. Default layer. Let me just move it to the side. So this one tends to make a lot of vertical slabs, right? Like so. And this is because the points tend to stick to an equilibrium. So what I can do is I can basically say that, well, actually the points should multiply more, right? So if I say something like this, this will make it so that the points with 2 or 3 neighbors are going to start multiplying or become alive. And let's also increase the depths, or rather let's keep the depths at 4. Let's just see how this would behave, right? Let's change basically one thing at a time. Alright, and we need to run the simulation again after we change the birth rate. Let's hit the play button now and see how the mesh updated, right? So you can see that this one is much more porous than the previous one, and that's because when things get born more easily, the structure gets overcrowded much faster, and since it gets overcrowded, right, things start dying off. So you basically add more dynamic, I don't know how to call it, a dynamic layer to it, I guess. And it's just like a visual preference. You should definitely start looking at the interior spaces and so on that you create to actually evaluate these structures. But for now, I'm going to keep it as it is. Let's say I'll choose the vertical one. So let's say we have these 3, and out of these 3, I'll test it out with a tower. So basically, what you want to do to start preparing it for a 3D print, the first thing is you want to check if it's a closed solid, if it's a closed mesh. So you just select the mesh that you want to 3D print, you type in what, and basically what you want to find here is the closed polygon mesh line, right? As long as it's closed, it's going to 3D print out, or at least slice up. There are some issues with non-manifold edges and so on, but those just tend to make a weaker 3D print. The only issue if it wouldn't slice is if you have an open polygon mesh. Okay. And also I'm going to check this guy's bounding box. So I'm just going to type in bounding box. That. I'll type in distance and just check. No, we have 75.95 millimeters, and this is due to meshing. It increases the size of the bounding box a little bit, but that's fine. 75.95, same. So basically 76 millimeters, and the height is 196 millimeters. So that's fine. Now we need to export this. I'll just select my shape and I'll type in export. And I'll just go for let's go for tutorial, and I'll just type in, first of all, check the extension that it's STL, stereolithography, and we'll be using some sort of a YouTube video print, something like that. I'll hit save. Then it asks me whether or not I want a binary or ACII version, or the file type. We use binary, And export open objects should be unticked so that it would start complaining if accidentally you're trying to export an open object. And hit OK. And it's going to save it. So now we need to navigate to it. Tutorials. There we go. YouTube video print.stl. Open up Cura. And just drag and drop it in. So now, setting up the 3D printers. Basically, in Lund, what we have is we have 3 different 3D printers. 2 of them are based on Prusa i3 Mark III, and one of them is a Wasp 3D printer. So first of all, let's set up the most common one, the Prusa i3 Mark III. If you go here and you click on Manage Printers, you can also go to Settings, Printer, Manage Printers. You can add a new one. So let's add a new one. Hit Add Printer. Let's go to Other and just find Prusa i3 Mark II. Prusa i3 Mark II. That one. Rename it to Prusa i3 Mark III. Basically, we're using the Prusa i3 Mark II profile because we're too lazy to download the Prusa i3 Mark III profile from their website, and they didn't change much between the 2 versions, well, except some hardware and hardware improvements. So this suits it perfectly. Suits the newer version perfectly as well. So Prusa i3 Mark III, add printer. So it's gonna add it to the local printers list, right? And for this one, we can just hit close, right? So that's our printer, and you can see it's barely fitting in this printer. The 19.6 millimeter height model. So first things first, if you're in the recommended tab, go immediately to the custom tab and let's start looking into things, right? Quality here, it's basically, since it's slicing up the model in Z direction, right? Since it's making a bunch of slices, this is how dense those slices are, layer height, how dense those slices are. So in this case, since it's a pretty big print, we should use, for the regular Prusa i3 Mark III, we should use layer height of 0.2. And initial layer height should also be the same, 0.2. If you don't see the initial layer height or any of the options that I'll be showing here, if you hover your mouse over one of the tabs, either one of the tabs, if you hover your mouse over it, this kind of a gear icon appears. If you click it, basically all of the hidden settings will be presented to you. And here, let's say you don't see the initial layer height. You can then tick mark it here, right? And then it's going to appear in your side menu on the right side, right? So for here, I'm just using layer height, initial layer height, and line width for the quality. I'm going to close this, and basically you want 0.2, 0.2, 0.4. This one will always stay at 0.4, and that's fine. Let's minimize this. Now for shell. So with shell, what you want to deal with is wall line count. Again, if you don't see these options, click on the gear and just navigate and tick mark the ones that you want to see. So here, even the wall thickness and the top bottom thickness, let's go for top thickness and bottom thickness. About these we don't care about at all. What we care about is the line count, right, and how many layers. So for walls we need 2 layers or 2 lines, For top layers we need 4, bottom layers 4 as well. This will just make sure that our prints are pretty high quality. If you want to have a strong print, then you use wall line count of 3. And maybe for this one I would suggest using wall line count of 3. But now, to save time, I'll just use 2. Okay. Infill. Basically always use cubic infill, and infill density of 20 is fine. Using something like 15 should be also okay. Don't go below 10%. This is just an inner structure that it's going to build inside of your 3D print. Material wise, 260 degrees for PLA plastic is absolutely okay, so we stick to that. All other settings are unnecessary. You could increase the initial layer flow to 110% to have better adhesion, but besides that, anything else is absolutely whatever. Speed. 60 millimeters per second print speed with travel speed of 120 is a bit low. We can have travel speed set to 200 millimeters per second. Initial layer speed though should be 25 millimeters per second to make sure that the print adheres to the print bed quite well. Travel Z-hop when retracted should be always on, and Z-hop height should be 0.5 millimeters. So that basically when it prints and it needs to travel from one part to another, it lifts the print head a little bit, and this will make sure that your print head doesn't accidentally bump your print off the print plate. Cooling wise, 100% cooling at the second layer, that's okay. Support, yeah, for this structure you can see here with the red, Cura shows us where it would need supports to work. So we'll say, yeah, generate the supports. Support overhang angle of 50 degrees is very conservative. We can use 65 easily. Yeah, everything else we don't need to change. Just make sure that support placement is set to everywhere rather than touching build plate, right? So it needs to be everywhere here. So it's going to generate supports for us. Build plate adhesion. For this type of model, you need a brim. Basically, once we start slicing it up, you'll see what I mean by brim, but basically it just makes it so that there's a higher surface area touching the build plate, right? So let's use brim here. Brim line count 20, that's fine. We can keep it at 20. Dual extrusion, we don't have any dual extruders in the school, so we don't care about that. Special modes, nope. Experimental, nope. Okay, so then once you have all of the settings down, you just hit prepare. It's going to say that it's slicing, and it's going to slice up your model and prepare it for 3D printing. Yeah, once it's done, you're going to see how long it's gonna take, how much meters of filament it's gonna use, and how many grams of filament, how many grams it's gonna use. And if you hover your mouse over the hours, it's going to say that, yeah, the infill is going to take 17%, the inner walls 13%, outer wall 24%, and so on. So we can check which part takes the longest. In this case, it seems to be pretty balanced out. So what I'm going to do is I'm just going to check the layer view here, like so, which will show me where all of the supports are going to be. If you don't see this colorized, then in the color scheme here, you should change from material color to line type, right? And it's going to show me, you know, how the 3D print is going to look like once it's finished. Seems to be quite a few supports here, but nothing major. Definitely definitely something that's cleanable. And then here, if I slide the slider way down, let's say till the middle, till somewhere near the middle, you can see the yellow lines here. That's the infill, right? So infill helps the part stay strong, as well as it helps with the contraction and expansion of the plastic once it's cooling down. And that's why we use at least 10% of the infill. And here in the bottom, you'll find how many parts that you have are like how many actual 3D print parts are going to touch the build plate. And here I only see a circle right here and just a few dots here and here. So I need to fix it a little bit. I'm basically going to select my part and I'm going to move it down by, let's go for 5 millimeters, minus 5. Whoa, 5 was way too much. Let's do minus 2 millimeters. Yeah, that should be better. And I'll hit prepare again. Alright, so now it's going to process the layers so that it can display them for me. So now if I slice it down, if I slide the slider down, I can see that I have full-on adhesion here, 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 and on these 4 parts. So I'm making sure that it starts the print right from the build plate, right? And nothing rests on the supports. So the brim is these perimeters right here, which will just make it so that everything sticks better and I have a bigger surface area that's sticking to the build plate and it doesn't peel off. But basically, yeah, in 18.5 hours with Prusa i3 you will have this kind of a print. So now if you're in a rush, right, and you need to print this out quicker, Prusa i3 quality wise, you can go as high as 0.3 millimeters. And if you choose that and hit prepare, and by the way, you cannot have higher layer height at higher than 0.3 with this particular machine. So this is the you know, the lowest quality that you can possibly go for. So then it drops down to 12 hours, right? Of course, the amount of material used is going to stay the same, but the hours are dropped down quite drastically, right? Quality wise, it should still be pretty okay. Shouldn't be, yeah, should be quite good. So 0.2 millimeters for really good quality, 0.3 millimeters for average quality, with the regular Prusa i3. So in the school we also have Prusa i3 Mark IIIs, or a single one actually, that has a 0.6 millimeter nozzle. So these ones by default run 0.4 millimeter, and we have one with 0.6, which means we can have higher layer heights. But basically, to work with it, you need to have another 3D printer profile set up. So I'm going to do that. If I go to settings now and go to printer and settings, printer, add printer, I can add a new one. So I'll go to others, choose Prusa i3 Mark II, again, same one. Make sure that it's Mark II and not just the regular i3. So i3 Mark II, I'm going to rename it to Mark III, and I'll say, also I'm gonna add 0.6 millimeter nozzle, so that I know that this one, this profile is for a larger nozzle. I'm gonna add the printer, right? And it's immediately, once I hit add, it's immediately going to jump to that particular new printer. And I can choose between them here. If I just click on this tab, I can choose between them right here. So here I have 0.6 millimeter nozzle, and here I can start playing around with the layer heights and so on. Before I do that, I'll go to the recommended tab, and I'll choose to have the layer height at 0.4, right? And I'll go back here and then we'll see what we need to change. So first things first, since this machine runs a 0.6 millimeter nozzle, I need to change its settings a little bit. So what I'm going to do is I'm going to go to settings, printer, manage printers. Make sure that I've highlighted the one with the 0.6 millimeter nozzle, and I'm gonna click on machine settings. So here I don't need to change anything, but in the extruder 1 tab, I need to change the nozzle size from 0.4 to 0.6 millimeters. Then click close, close here. Yeah. So now this one is gonna run, it's basically, it knows that it's running a 0.6 millimeter nozzle, so immediately the line width updates automatically to 0.6 millimeters, right? For layer heights, I'm going to use layer height of 0.4, initial layer height, same number, always the same number, 0.4. Shell wise, wall line count, let's go for 2. Never go lower than 2 walls or 2 wall lines. Top layers 3, bottom layers 3, something like that. Infill 15%, or let's go for 10% infill. Material. So now, since we're running a thicker nozzle or wider nozzle, it's going to push out quite a lot of filament. So we need to have it a bit hotter so that there's no resistance in the plastic. So I'm going to use something like 205, maybe 210. Let's go for 205, yeah, 205. An initial layer flow, again 110%, right? Speed wise, we can keep this at 60, travel speed 200, initial layer. It's basically the same settings as with the original one. Cooling, same settings as the original one. Support, yep, generate support, and 65 degrees. Build plate adhesion, brim. This time you don't need 20 lines because the lines are gonna be wider since we're using a wider nozzle, so 14 lines is fine. Dual extrusion, special modes, and experimental, we don't care about those. Okay, so now if I click prepare, it's going to slice it up according to a 0.4 millimeter layer height, which is quite coarse, but it still produces a decent, really decent print, right? And that one will only take 8 hours, right? So from 18 hours we dropped down to 12 hours, and now we're running at an 8 hour print. We can go even faster than this, even quicker. Basically the rule of thumb is you can never go lower than 75% of your nozzle, or sorry, 80% of your nozzle. If I run a calculator, so the idea is that your layer height cannot be higher than 80% of your nozzle diameter, right? So our nozzle diameter is 0.6 and 80% of it is 0.48, right? So you can go as far as 0.45 and still be okay with it. I don't suggest that. 0.42 millimeters is the maximum that I would go, but basically just changing this to 0.42 should be the quickest that you can print it. Well, except one more thing that we're going to change, which would make it even quicker, but that would make it more susceptible to failure. Basically, if this is not quick enough, then you can go to speed, and you can change the print speed to something around 75 millimeters per second. If we hit prepare now with 75 millimeters per second, we should see something like 6.5 hours or something like that. Maybe 7. Yeah, 7 hours. So this is like lowest quality but fastest print speed. Highest quality and slowest print speed would be 18 hours for the same geometry. So this is for right now we've set up our 2 printers which we have in the school. The third type is WASP Delta 4070 printer, which is a bit different. It's not a Cartesian printer. It's a Delta type printer, meaning that the build plate is oval. So to set it up, we go to Settings, Printer, Add Printer. We go to Other, and here under Delta you'll find Delta Bot. So I'm going to rename this to WASP 4070. Add printer. Like that. And now we need to change quite a few dimensions of this. Basically the Delta Bot has the same shape as the WASP printer. No, the difference is that the WASP printer is much bigger. So if we go to here to WASP Manage Printers, Machine Settings, here the first thing is X width and Y depth, right? So these guys need to be 400 millimeters. 400. Z height should be 700 millimeters. So it's a pretty big machine, right? 447. Extruder nozzle size should be 0.4 millimeters. Okay. Besides these 4 things, we don't need to change anything else. So we hit close. Hit close here. So now we can see the the actual size of the machine, right? To start slicing it up, the layer height 0.2, initial layer height 0.3, that's all fine. Shell, wall line count 2 for 4, that's okay. Infill, that's fine. Material, you can run it a bit hotter, 205 is okay. I'll keep it at 200. I tend to stick to 260 degrees, and if something's wrong then I start changing these up a little bit. Speed wise, print speed can be much higher than 30 millimeters per second. We can change this to 90 millimeters per second, and travel speed can be 200 millimeters per second, and initial layer speed should stay at 25. So initial layer speed, it doesn't matter what kind of printer you're using. To my knowledge, it always needs to be pretty low to have the biggest chance of success. So 25 typically tends to work, so I stick to 25. So 90 to 125. Then we have travel, z-hop when retracted, always yes. Z-hop height 0.5 millimeters. Cooling, all of this is fine. Support, yes, generate support. Overhang angle for 65 degrees. Build plate adhesion, brim, 20 lines. Yeah. Dual extrusion, special modes and experimental, as always, we ignore. So this machine can run a bit faster, like 90 millimeters per second, because its build plate is fixed and the only thing that's moving is the nozzle. So there's no additional vibration of the model since it's not running on a track or anything. So here, for the same quality that we would get with a Prusa 3 Mark III at for an 18-hour print, here we can have the same quality in 12.5 hours, which is quite nice. Yeah, and that's basically it. To save the G-code, basically if you take one of the SD cards from the machines and you put it in your laptop or your computer, it's going to say save to removable drive here, or you can just save to file and just save it as a G-code file, and then once you have access to the SD card of these 3D printers, you can just add that G-code file there. And the G-code file is basically a list of instructions for the machine on how to print it. Yeah, and that's basically it.